Afternoon. Today we are going to discuss about RAG, that is retrieval augmented generation, and it's quite widely used inside the industry for different applications. So we will cover some topics today, like why RAG is needed, what is the architecture, and the evaluation techniques for the RAG. So let's first talk about the need for RAG. Why the RAG was needed? We already have the LLMs which were doing a great answer, doing great answers. Then why we were needing RAG? See, the problem with the LLM was they were trained on public available data. So they do not have access to your project specific data or your personal data until unless you don't upload it. So that is one of the reasons that many times the projects or the clients were, their main intention is to work on the data which they have rather than the data which is publicly available. So LLM was not able to answer on the privately available data or the project specific data. So that was one limitation. Second was, even if we do this like if we upload the data to the LLMs to give us the answers and all those things, then there are also a privacy and security concerns from the different companies. They don't want their data to be uploaded to LLMs or on a public available LLM. So that was also security, privacy and security concerns. And third was hallucination. So even if they don't want to do that data, upload the data with the public available data, as we mentioned in the point one, there are a lot of hallucination was happening, like the query which was asked and the answers which was coming was miles away from the relevancy point of view. So that's where the RAG came into context, where it solves the problem that the data which is available personally or project specific, that can be used by LLM to generate a very precise and accurate answers. So that was the need for RAG. So now comes to the other point. What is the architecture of RAG? So the RAG architecture is basically, if we try to distribute it, it's a 10 step architecture. So we can just go through it. So for example, the first stage is that, as we discussed, that the limitation was LLM was not having access to the private data. The first step is collect all of your project specific and private data. So that is your PDF and any format like PDF, docx, txt, all the data could be collected and then they can be parsed. So we have different parsers for different type of files. For example, PDF can have a different parsers, docx can have a different parser, text can be parsed differently. So we can use different parsing techniques to parse these data. And step 3 we can do chunking of these data. So we cannot process all the data at once, so we divide them into chunks. Like chunks is a like size of the data which we want to process. So it could be 512 or tokens, it could be 1024 tokens. So it depends like what chunking we want. So the third step was chunking. The fourth step is embeddings. So machine learning or the LLMs does not process the text in the format which we see. So they work on the numbers format. So embeddings convert these text into numbers or vectors. So all the text chunk data which was present into the text converted into the numbers via embedding, and then they get stored into the vector database. Vector database, as step 5, stores all the embeddings from the different chunks. So now once your data sits in the vector database, so that means your input documents, now all these input documents that sits here is in this particular database. So the sixth step is query. So the user can come and give a query that, okay, I want to know a particular status of a ticket or anything. So the query will get embedded first. So because we want to find that, okay, which vectors which is present in the vector database is close to my query embeddings. So that is called semantic retrieval. So once we embed the query and we search the query into the vector database, we get the semantic retrieval, like we get the context which is relevant to us. So now when we go to LLM, so we not only sending the query, what was the query asked, we are also sending the context. So for example, from this input docs you got around 500 chunks. So for this particular queries might be only 5 chunks would be relevant. So now instead of sending the entire set of data, it sends the context, that is the retrieved chunks. Now when this context plus query sent to LLM, it generates the answers, and the answer is more precise, accurate, and relevant to the uh, data which is present in your project or what you require. So this was a simple standard RAG architecture. Now once you implement the architecture, you also want to evaluate it. So there are several pipelines, or sorry, several open source frameworks which are available, which you can use specifically to evaluate the RAG pipeline. So one of the framework is Ragas, other is the DPWell, third is you can derive your custom framework as well. So you can use LLM as a judge, and you can check whether the retrieval which is happening is based on your project data, is how much accurate it is, how much deeper coverage it is able to retrieve. So you can do this evaluation accordingly. Thanks for watching this.